So that's why on Mondays I have to go as long because if not, it'll look a way in the it'll look
All right, guys. Last thing about uniform distributions, real quick. All right. Let's see if I can say this correctly. The homework is going to ask questions about the mean and the standard deviation for a uniform distribution. I'm going to have a problem on the practice test related to the mean and standard deviation of a uniform distribution. But past that, I'm not going to care too much about it. So some people hear that as, oh, I don't have to worry about that shit. No, there's more to it. Can anybody see what the mean of this one specifically, but any uniform distribution has to be? If this is the amount of time I gotta wait for something, what's the average amount of time that I have to wait for that thing? So it can be anything from 10 to 26, equally likely. So what's the average amount of time? What do you do to figure out the average? What do you think you could do?
Just the middle, right?
Just the middle.
So it would be Q2?
Well, it's not even, you would be, but you don't even have to worry about that. It's just the middle of those. How do you find the middle of two numbers? Add about 5 by 2. So no matter what these are, I'm going to add them, divide by 2. So in general, for any uniform, well, this is a neat question. You ready? See how it could be A or B, could be anything, even negative, whatever. What's the height? How did they get 16? That minus that, under 1. So that minus that, yes. Okay, I like it. See how formulas very often make it look worse than it really is? Because they have to cover every situation, that's why. Okay, stay with me now. So what's the average of this going to be? The mean would be A plus B divided by 2. And here's the one I was referencing yesterday that was going to show up. The standard deviation is going to be the square root of b minus a squared divided by, of course, 12. I love that. Now again, like I told you, anybody, if enough people want it, I'll just bring a copy for everybody of the proof for this. Yes? How did they get the b minus a squared? Do you see what I'm saying? Any part of that you should be like, how did you get that? How did you get that? I didn't just show you how to get there because, again, it's based on math that most of us don't have. Again, calculus is really behind a lot of the stuff. This is one reason why I want you to know these exist, because remember what I said before. Every time they give me a different way to represent data. Binomial, we wanted to know what the mean and standard. XP of x, we got to figure out what the mean and standard deviation is. Uniform, I got to be able to figure out what the mean and the standard deviation is, because that's the two best numbers to represent something. So I want you to know that there are formulas that exist for uniform, and if you are curious as to where that formula came from, I will show you. But if you don't know calculus, I'm not going to try to teach you sitting in my office calculus, but you can at least see where kind of things came from, if you want to.
Why is there 12? Is that also part of that whole? Okay.
So it just comes out of the proof of the steps. That's all it is. It just comes out of the steps of the math. It's not 12 because there are 12 math gods on the top of the mountain over there. So we divide by 12 as the 12 math gods, right? And if one of them goes away, then it's 11. No. It's 12 just because that's how the math worked out. It just came out of all the steps of math. So is there some magical property of 12? No, it's just the combination of some other numbers that came out to be 12 at the end. That's all. Nothing magic. I like it. It's sort of like, I understand, because what's this 2 represent? There's 2 numbers I want to average, okay, right? So you're like, what's that 12 represent? No, it just came from a lot of other numbers, came together, and they were 12. 12 doesn't mean something by itself. Okay, enough of that. So I really hope you understand. I want you to know that these exist for this, and I want you to work some problem. If I know, what's the standard deviation for this? The mean was 18, is that cool? What's the standard deviation going to be? It's going to be square root of 26 minus 10 squared divided by 12. So it'll be 16 squared divided by 12. Let's see. You gonna do that in your head, Jeff? Yeah. 21. It's roughly 4 point. What is it? It's not on the right side of that. 21.3333. I don't know if anybody else is doing that. Wait, have we taken a square root yet? No, it's not square rooted yet. So it's 4 points, 4.618?
Yeah.
Is that cool? I mean, again, it's just a formula. What are P and A? The endpoints, and you can plug it in the formula. I love, and this is the way you should be, those of you who are like, but I want to know where that came from. That's beautiful. And some of you guys are like, I don't want to know that, and I don't want to know it. All right, too bad. You're going to have to use it. Too bad. You just plug B and A in there. All right, so hopefully you understand. I'm trying to walk a line here. I want you to know every distribution we work with, there is a way to discover these 2 numbers. But the math behind putting this together is beyond most of us. If you do know calculus, I can show you. You can see where it came from. Okay. So this is not going to even sit on our formula sheet. So I'm not going to ask you a question on the test about it. That doesn't mean it's not important. I don't know if you guys can realize that.
This isn't gonna
See, right there, it's like, oh, okay. No, I'm not going to ask you a question about that on the test. You still got to do it in the homework. That's a problem I'm definitely going to be looking for. It's just plug and chug shit. Okay. All right. Let me try to show you. All right. And I keep bringing this up, but hopefully you're a student who realizes I want to flesh out an idea further. I'm about to show you an example of a problem you'll never have to do, not even in the homework. That doesn't mean it's not important, doesn't mean you shouldn't try to understand it. There are distributions that are triangular shaped. The same considerations happen. I don't want to do a lot of math for this because like I just said, you're not going to have to worry about this kind of problem, but I want you to realize what we did with a beautiful rectangle. The idea behind what we did doesn't give a shit what the shape is, really. Can anybody help me out as to what the height's going to be? And if don't say 1/6, because you're wrong, because what shape is this? I want the area of this triangle to be 1. Thank you. So then it's a accumulation of all the probabilities. I want to make it become 1. So, but the height, of course, is not 1/6. But the area, what's the area of a triangle? 1/2 base times height. And I want that to be 1. What's the base? 6. You guys kind of with me?
Yeah.
Half of 6 is divided by 3, so the height is 1/3. Now, let me show you why I'm not going to make us do problem. Now, you guys get a feel for this? So I just want you to realize there's nothing special about the rectangle. It was just made everything easy. Little rectangles inside of big rectangles in area. Oh, beautiful. Yes, please, dear Jeff. Give me those problems. Do you realize this kind of problem was so... quickly suck. And if I want to know the probability that it's between 11 and, what do you got, Jeff? 14. What kind of shape is this? It's not even a real shape, right? But you could still use, you'd have to use algebra to figure out how far up those go. And then you can kind of break it up into some shapes and get the area. So it's still a question about getting the area. Geometry will still work. It's just immediately a lot worse than a rectangle. Do you guys agree? I could ask a slightly better, easier question. What if I just said the probability that it's less than 11? The only thing I then need to know to get the area of this is how far up does that go? Right? You guys see that? And then I'm not going to go to, I really hope some of you guys can realize, isn't that 13 there? Isn't there an equation of this line? Can't you figure out what that point is knowing this? If you know the equation. So there's a ton of algebra in that shit. Do you see that? What I want you to get from this is, I had to get a height, just like we did with rectangles. Any question they ask me, if I can draw it and get the area, I got to focus on how do I get the area. Doing those two things are worse, but they don't change. I still have to do those two things. Okay, so we're about to actually go do something even worse than this, but thank God I'm going to have computers that calculated all the areas for me. So this is still nice. Do you see why this is still nice? Because I still have geometric formulas that apply to the pieces of this. Triangles and trapezoids and shit. Oh my. You guys kind of with me? A little bit? Because if I did this area here, what shape is this? It's a trapezoid. Yes, cool, I like it. Anyway, so you could use geometrical formulas for areas of trapezoids to get that. You could. You really could if I forced you to. Well, that's beyond the scope of what we do, but don't worry about it. Now, what's a normal curve look like? It looks normal, I think. Starts. Well, you all know what it looks like, right? Do it in the air for me. What's a normal curve look like? A normal distribution, a bell curve, right? It's the other name for it. All right. Wah! I had somebody that could not draw that, so I just let them draw triangles, because when I do these, I just need a visual to label shit, just so I can see what's going on. Hopefully you can draw a little ghost dude there, right? Maybe. Do you see how geometry looks at that and goes, no. Because this is nothing. Geometry can't handle a shape. If I want to know from here to here, this side is all curvy. Okay, I like it. You guys, everybody with me? At least this one, it was worse. It was much worse than a rectangle, but it still is just basic algebra and geometry. That one, no. And again, I anytime I bring this up, I don't mean to make you feel like you're supposed to know this or anything, but one thing that calculus does, one of the most basic things it does, is it figures out areas under any curve. I don't care what it's shaped like, it can figure out the area under it. And we had a computer crank out all these areas, and I got a chart I'm going to give you. But the idea doesn't change. The answer, so if I knew, let's say I have a normal distribution. Yeah, normal distribution. Does anybody remember what the probability is that a z-score is between -1 and 1? It's within 1 standard deviation of the mean. Good, I love it. 68%. So what should the probability of, there. All right, here we go, Jeff. 2. What's the probability that z is less than -1? Can you figure it out from the picture? What must this be? You can do it. Now think about it. Don't say anything out loud. 68% in the middle. What's true about the picture? It is symmetric. So there's 68 in the middle. How much is out here? 32%. We're going to catch up to you. I know you got it. So how much is on that side? There's 32% outside total. So how much is on this side alone? 16. You guys, everybody see that? Nothing amazing. Just because it's symmetric and I know what's in the middle, so I must know what's on the outsides. Right? Because the whole thing is what? The whole thing makes 100% or 1. So there must be 16% here. So one of the first things I want to do with you with this chart is first explain how the hell to read it, and then see the chart give me this answer. If it don't give me this answer for this, screw the chart. I'm going to set it on fire, forget about half the class, go get a drink or something. Too bad for you, that ain't going to happen. Every time I say that, I'm like, I'm going to make some stupid mistake, and it's not going to come out right. And, I'm going to go get a drink. Oh. Yeah. Oh. Missing people, man. Okay. I don't know. This might be a little intimidating. I don't know. So let's look at this. It has to be because you've never seen it. Huh?
There's like the class left in the first day of school.
Yes. Not really. The number of enrolled is not equal to the number who are here right now. Yes. So some people just were like, I need a day off, which I understand, but maybe I shouldn't post the video. No, I'm not the evil yet. All right. So I want you to notice something. 0 is definitely in the middle. Because somebody remind me, z-scores tell you what? Yes, how many standard deviations from the mean to the data point you're interested in. So how far is the mean away from itself? So the mean will always be 0 on a z-score picture. Is everybody with me? And let me tell you this right now. Since you guys are here, maybe I should cover this guy's ears. I don't know. No. On the next 2 tests, we only have 2 more tests, the test and then a final, right? I'm going to ask you this question. I'm going to ask you, either I can ask it this way. I can say, what does the z-score tell you? The number of standard deviations from the mean to the data point. Right? Or I could say, what would a z-score of 1.87 mean for a data point? That means that data point is 1.87 standard deviations from the mean. Don't make me, I am a dork. Don't make me have my dorkiness come out and you just say it's 1.7 away and I'm like, miles? Light years? You know, but I'm going to do that. I can't stop myself. Shoes? It's 1.87 shoes. No. So you got to have units. What are the units? Standard deviations. That's what it measures. How many steps? How many standard? Don't say steps either. Remember I said that. Talking about it, steps makes a lot of sense. It's very visual, but it is standard deviations. You guys semi with me? Yes. Oh. So either, yeah, so it would be something like, what would a z-score of negative 1.29? That means that data point is 1.29 standard deviations below the mean. That's the negative piece, right? It's below. Are you with me? So do you see how this is split up into positive and negative? When I look up a z-score, the answer it gives me is the area below the z-score. The picture reminds you of that. So what should be below 0? What percentage is below 0? 50%, because that cuts it in half. So when I look up 0.00, I get 50%. If I wanted to look up 0.23, 0.23. This row is the second decimal place. It was just the way we could do it to show everybody the most information on one sheet. You guys see that? So you got to get used to how to read this. Where's 1.41? 1.41. So it's right there, 92% below 1.41. So if I got a 1.41, there's 92%. If I got a 1.41 Z-score on the test, 92% of the students scored below me. It's a 92nd percentile. Another way to look at it. You guys with me? So 1.4 Z-score on a test is really good. Even if your grade was 37. That means it was a suck-ass test. It was like me in grad school. I got a 42, and he's like, good job. I'm like, what is happening? What do you mean, good job? Because the average was 30. Oh shit, okay. Anyway. So, I want to right now see if the chart gives me the right answer for Z-score -1. What would be -1.00? Can you guys find -1.00? So we got to look at the negative side. -1.00. You guys see that?
Yeah.
If you round that, it's 16%. So for that rule we talked about, to make it easier to remember, we rounded the numbers. So it is actually 15.87, but we just made it 16 as part of the rule. Are you guys with me? So with the empirical rule, I can figure out only certain numbers that are related to these whole number steps. With this sucker, you can figure out anything. So let's do a couple real quick together. Let's do some together. Let me try to do everything up here. That makes sense, Jeff. I just had paper. Here we go. I got paper. All right. So let's try to do this. Try to draw this situation. What's the probability that Z is less than -1.94? So here's how you draw this. So of course you make it normal. The instructions on the problem, by the way, would say you have a standard normal distribution. Standard just means they've been converted to Z-scores. So what's going to be right in the middle? 0. Where's -1.94? Yes, dear God, please. The picture is supposed to help you. If you put things in the wrong place, picture ain't going to help you. Worth editing, right? -1.94 is over here somewhere. Doesn't have to be perfect, just over there somewhere. Can you shade in the area the problem wants me to find? Yeah, probably Z less than. That little inequality is an arrow pointing you what way to shade, right? So I want this area right there. Now, I didn't make my picture perfect, but I know that that area should be kind of small. Definitely less than 50%, right? So I already know a few things from just the picture. Okay, now, take a minute and look it up. Don't say it out loud. Try to find that -1.94. What's the area below that score? What's the probability I get something less than that score? Don't say it out loud yet. So I gotta go to the negative side. -1.94. By the way, what you're gonna notice this if you haven't already. It kind of sucks the first one is 0. Because a lot of times I have -1.9, 1, 2, 3, 4. No, it isn't. That's the answer. Ah, shit. So 0.0262. Is that cool? You guys with me? So it's less than 3% out there. And that makes visual sense. It makes sense because what did we say was true about 2 steps away? Anything outside of 2 steps away would be really unusual. And that's less than 3% chance. That's almost 2 steps down. That makes sense. It should be pretty unusual to be down there. Always helpful. Now, what about this question? What's different about this question? Take a minute and try to draw this question. Z greater than 0.19. Guys, there's something about this question that makes it just a little bit, you got to be more careful. Here's 0, where's 0.19? A little bit up here somewhere, right? Where's the area that I want? Okay. But that reference is not so old now. Make my own lyrics, so it's almost the same. What's different? What is the chart? What's the only areas that the chart understands? Areas to the left. So how do I get this then? How do I get this? Yeah, so what's this side? So if I look up 0.19, 0.1, 5753. So this is 0.5753, but since you shaded this in, you know you're not done. That's why you want to be nice to yourself. Problems are hard enough already. If you represent them correctly, you can tell if you're done or not. I know I'm not done. I got to answer this question. If you remember what I was saying earlier, well, probably if I show you what I'm doing. 4, 2, 4, 7. Right? Make it 9, make it 9, make it 9, make it 10. This is why I showed you that yesterday. Or just do 1 minus that in your calculator and put it back. Now, are you guys somebody who decent with that? The chart, there's just one two-sided piece of paper. So you should understand that some questions are not going to jive with how it's set up. So we have to do little adjustments, and that's the most basic one is 1 minus to get the other side. Look up negative 0.19 for me. What do you see? Negative 0.19. You get this, you get this, don't you? Holy shit. Well, of course, the area above 0.19 is the same as the area below negative 1.9, isn't it? 0.19. That's a shortcut you could use. If you don't understand it, never use it. It's that simple. It's not even that huge of a shortcut. You shaved off a half a second. Good job. But it's still kind of neat. You can just look up the negative. Sometimes, if you don't know when, don't. Right? Just don't do it. Okay, maybe. All right. Now let me let you guys try to figure this out. And then I got a little handout. Of course I do. Oh, I forgot about that whole other side, but oh well. It's too bad. We did enough of that stuff. Try to figure this out. Put something down. Leave me alone. I like it. Where's the area that I'm curious about? It's this area, right? The chart totally can't handle that shit. But I can still use the chart to get this answer. What do I do? Yeah, if I look up the area for this, that's going to be way too much area, right? Because it goes all the way down. That's what the chart does. Very single-minded. Exactly how much too much is this? Exactly this much too much. So if I get this area, and then subtract them, it's going to leave me the area between. So these are the kind of adjustments we have to make. That's a balancing act, so I don't have a whole freaking volume of z-scores. I just have one sheet of z-scores. I have to be okay with doing this kind of adjustment work. So what do you get when you look up 3.27? 3.27. Yeah. 9995, right? So 9995. Oh, let me make a big deal out of something. This isn't just arbitrary. Do you see how I always put z-scores down here? Areas up here. Because areas can look like z-scores. So if I just said 0.76, is that an area or a z-score? Could be either one. Oh, shit. So I identify what it is and I put it in the right place. And what goes here? You look at 191. I get 9713. Is that right?
No. 9719.
Where do you go? 19. Oh, look at you guys saving me. You get 9719. Thank you. So then this will be 9719. So how do I get the area in here? Subtract those two. Kick ass. So 0.0276. I don't know if I trust myself now today.
78.
78. Did I write this down? 9995 and 9719, right? 0276, yeah. Alright. Some of you guys are like, let's make him feel like he's going crazy. Okay, so if I have a situation, let's do this first. What if I had a standard normal distribution? Right? And I want to find a z-score that is P17. What does P17 mean? 17th percentile. Yes. Okay. So what would that look like? Where does it have to be then? Could it be up here? Could it be right here? Because this would be what? P50. So P17. So why did I put it down there? Because it's got to be the z-score that has what